Hi, this is Amin, and finally this is the last part of the BGP concept and configuration videos. So after talking a lot about the concept of the BGP, about how to do the configuration, about the importance of each step, so now it is the time to take a look at the real scenario like this on the GNS3 to have better understanding about the whole topic. And at the end of this video, I'm going to add another AS to the system and do all of the configurations. I mean, I'm going to start from scratch and show you all of them step by step to learn it better and better. So this is the first AS, which is AS number 1, and they are connected via RIP routing protocol. So as I've told you, inside one AS, all of them should be connected to each other. I mean, so RIP routing is for IGP, and also Ipvgp protocol is set up already. And we have another AS here, which is AS number 2, and AS number 3, which is here. So here we have OSPF, and here, as this is just a single router, there is no need to do any, any sort of dynamic or static routing protocol. So let's see the configurations and see what we learn. Here I have PuTTY. So on R1, let's do a show run to show you. Look, interface loopback 0, as I wanted to advertise my loopback as a network as well. So I've chosen this subnet for that. Interface number 1, number 2, and this is the RIP routing protocol. So for the sake of simplicity, I've chosen all of them in a network like this, so the routing via RIP would be pretty easier. No auto summary and all of the networks. If you can remember, I've told you about this topic that when we have a crowded AS, which will be most of the time the situation, it is better to have a peer group. So we have peer group here, and this is the name that I've chosen for that peer 1. So we just set up a peer group and add everything to that peer group. I mean, remove AS number 1. We can add a description, for example, Toronto. Update source loopback 0. I've told you this thing because in order to look, for example, here we can use this interface or this interface, but loopback is the interface which is reachable for the whole network. So it is better, I mean, in case one of the connections are done, you can actually reach to the network via this place, because your source is your loopback, and the next hop self, it is for loop prevention. It should be there, and also it will update the next hop. So you can add a description. I've told you can add a timer. So the first number, what is the first number? This one is the keep alive timer. So every 30 seconds, they're going to check the keep alive, and this is the hold time. This one is the hold time, this one is the keep alive, and just easily after that, you're going to add the peers like this. And this is, look, we can see here router BGP number 1, so this is my AS number, and here remove AS number 2, so this means that this one is Ipvgp external. So what is the rest of the thing? I think the rest of the configurations are, yeah, it's okay. So this is for the R1. Let's go for example, R4, show Ipvgp summary. We can see here, look, this is local AS number is number 2, which is here, and this AS is 1, this AS is 3, so both of them are external BGP. And when we have nothing here, I mean, the state is empty, or you cannot see anything here, this means that this is established. So whenever you see something here, this it means there is a problem. So when there is nothing here, the situation is good. And the other command, what is the other command? Show Ipvgp. We can see clearly here. Perfect. So these are the networks that BGP is advertising. This mark, it means this is the best route. Look, here I've told you about, I think in the third episode, I've told you there are some parameters. The first one is the weight. So here for this network, there are two paths or two routes. So weight is the same, local preference is the same, there is no metric. Whenever there is the shortest path has the highest priority. So for this network, just there is a one AS number, so this one has the priority. And for that part, for example, and then we can take a look at here, show run to see the configuration. Yeah, we have our OSPF, we have our BGP, but see, let's see. Here, look, here there are three routers, and also here there are three routers. At that step, I tried to use a peer group, but here I didn't use the peer group. We can see repetition of the numbers, 6666 or 777, but here you just add it once. So this is for the router 5, and the whole situation is the same. So far we know that there are different AS numbers and different paths, and this is something which is important. For example, on R4, yeah, we can see easily for all of them, there is an alternative route, and based on the attributes, BGP has chosen which one is better. So what is the next step? I'm gonna add two new routers here. I'm gonna add two new routers, yep. And then I'm gonna connect them to each other. For example, this one to this. And after that, I'm gonna connect this one to this one. And finally this to this. Good, perfect. These two routers will be my new AS. So let's choose a name for that. AS number 4. I'm gonna pause this video and just type these numbers and names, and then I'm gonna continue. So let's continue the recording. After adding all of these routers, now it is the time to do all of the configurations. Let's start from R8. Let's first do the internal, whatever which is internal. Let's go to the R8. So what do we have? First of all, they are connected via serial interface. So interface serial, I think 3.0, yep, no shot. And IP address would be 192.168.5.1, 255, 255, 255, 252, and do the no shot, and interface loopback 0, no shot. IP address would be 8.8.8.8, 255, 255, 255, 0. I told you I want it as a network to advertise. And on the other side, what else do we need? Interface FA00, no shot. And IP address is 192.168.4.2, 255, 255, 255, 252. So, yep. So we are good. These all networks are, and all of the interfaces are configured. Let's go for the routing. Router BGP, for example, 1. Let's add the networks. Network 192.168.5.0, network.4.0, network 8.8.8.0, and at the end, note to summary. Then router BGP reach number, the AS number, which is 4, router BGP 4. So first go for the network, which network that, before doing that, we have to see something. Do show IP route for 8.8.8.0. In the videos, I've told you about the subnet mask when you are going to add a network to the system, which is very important. How we should verify that with this command, show IP route, that specific network, and the subnet mask that you see here, you should add this one. So you'll type network 8.8.8.0, and the mask would be 255.255.255.0. Let's go for the neighbors. The first neighbor, I told you for the internal, so 99999. This is the IP address, and the remote AS will be the same. 4. After that, update source loopback 0, and next hop self. So this is for IBGP, and for E, I would just add like this neighbor 192.168.4.1, which will be this interface, and the remote AS will be what? 1. And it is done. Let's go to the R9 and do the rest of the things on R9. Config terminal, so interface serial 360, no shot, IP address is 192.168.5.2, 255.255.255.252. We can verify that, do ping 192.168.5.1, which is this interface. This is .1, this is .2, and this is the range. So very good. Interface, let's see. It was, I think, fast. Yeah. So interface FA00, no shot. IP address would be 192.168.5.2, 255.255.255. Oh, oops. I've made a mistake here. This one is 5 and this one is 5 as well, so I have to change it to 6. Yeah, this one should be 6. Okay, I think I was here. Yeah, FA00. So on FA00, what should I do? 252, but it is 6. So it is 6. Very good. And so I think on R9, just 2 interfaces and interface loopback 0, no shot, IP address 9.9.9.9, 255, 0, and okay, we're done, we're good. So what I'm gonna do, first check. I should be able to ping 8.8.8.8 with the source of loopback 0. I need to put it in front of that. I'm gonna ping 8.8.8. So I cannot, because the EIGRP should be set up. Router EIGRP1. So let's add the networks. Network 192.168.6.0, .5.0, and finally .9.9.0. We go back. I should be able to do that ping now. Yeah, that works. Perfect. So let's go for the BGP. Router BGP, the AS number is 4, router BGP 4, and before that, let's see, network 9.9.9.90, and the mask is 255.255.255.0. I've told you about the port of the BGP, which is 179. So let's do debug IPTCP transactions, and also do debug Ipvgp events. Ipvgp to see the port or things. So we are the router. Neighbor, this address 192.168.5.1. Here on R8, what we've added this one as the IBGP, EBGP, and the local of the 9. So here, it is better to do the same policy. 9.9.9.9, the remote AS is the same 4. So as they find each other, we'll see the logs about that. Cannot. Oops. Sorry. So this debugging will be annoying. Here. There you go. We can see. After finding each other, to show Ipvgp summary. Yeah, the session with 999 is active. It means, yeah, now it is up. So if we see, yeah, this active is not here. Perfect. And here we can see, look, the sync received, the sync message received. This is the port number, and the connection is on the queue. And yeah, perfect. Whatever we want. But this thing, I mean, debugging will be annoying. So I'm gonna just remove that thing this way. So no IP debug events, Ipvgp. We are good. Here we're good. What do we have to? Oops. I need to cancel debug about. Yeah. No debug. Control C. Debug IPTCP transactions. No. Debug Ipvgp events. No. Now it will be okay. So show Ipvgp summary. What do we have? Okay, just we have this one, which is up. We're gonna see. We're gonna go config terminal, router, BGP4. We add router BGP4, and we need to add this one. So neighbor, what is the IP address? It will be 192.168.6.1, and the remote AS will be 3 for that. Let's check the configuration that we've done so far. So we have one FA00, which is this one. The configuration is okay, and we have serial interface, which the configuration is correct, and a loopback. This is the router EIGRP. The no to sum. Oops, we need it needs no to summary. I'm gonna add that. And router BGP. So we need to add first router BGRP1, do the no auto summary, and let's go to the router BGP4. First, no synchronization, no auto summary. Good. And add the rest of the information. Neighbor 8.8.8.8, and next hop self, and loopback 0. And also here on router BGP4, no synchronization, no auto summary. Do show Ipvgp. We have these two networks, which is for Ipvgp. We are still inside the AS. And here do show Ipvgp, the same result, and do show Ipvgp summary. This one is active, which is for that interface. It's okay. And do show Ipvgp summary. The same, yeah. It's going to work. So we should go to the R3 and do what first? Set up this interface, which is FA00, and add it to the BGP. So the config terminal, interface FA00, no shot, IP address will be 192.168.4.1. 252. To verify that, I'm gonna ping the other side, 192.168.4.2. Yep. So let's go to the this is the router RIP. So router RIP at this one. This network 192.168.4.0, and then go to the router BGP. This is number 1, and the neighbor, which is 192.168.4.2, the other side, this side. So, and the remote AS will be 4. To show Ipvgp summary. Is idle, we should wait for that. It will be active. Yep, now it is up. On R3 we can see. All of them are up. So, look, this was the result of show Ipvgp. Do show Ipvgp again, and we'll see all of the networks which were here in the routing tables. All of them are now advertised inside that, as this router is connected to the Ipvgp, so all of the networks advertised, and also here you show Ipvgp. So we need to do what? We need to add this interface as well to the system. So I'm gonna do that exactly the same. First, let's go to R7, config terminal, which interface it is. Yeah, this is the interface, 10. So interface GI10, sorry. Interface GI10, no shot. IP address will be 192.168.6.1, 255, and they are connected via OSPF. So router OSPF 1, and network is 192.168.6.0, and the wildcard mask will be this. Oops, area 0. So go to the router BGP, which is the S number 3, and there's another neighbor which will be 192.168.6.1. That's 6.2 actually, sorry. That's 6.2, which will be this interface, and then the remote AS number is 4. To show Ipvgp summary, this is idle, never, we should wait for that. It will change. And also here, yeah, this is up, there you go. So do show Ipvgp. Now let's see the difference. Before that, I mean, just this interface was in the eBGP, and we had just one path in order to connect to the world outside. But here, after adding the second connection where this way, so look, the redundant routes are appeared. And if we keep on doing that, we'll see lots of things will add. Anyway, good. So far what we've done, we've added a new AS with new IP addresses to the system, which has redundancy, and it is good. Now it is the time to work on BGP attributes. Let's go to the R8 and see what can we do here. So we're gonna set a weight at first, and then go for local preference, and finally for the last thing that I'm gonna tell you, which is the AS path. So for which one it is better to work? Maybe, I don't know, maybe here, or on the all of them, maybe it is better. Yeah. So I'm gonna do what? We go to the global configuration mode. How we should do that? Look, the weight is 0, and we know that it has the highest priority. If we change that weight, so we can just change all of these marks. We should just type a route map. So we need a route map for that. And after that, it's a word. So I'm gonna add a name for that, and then what permit, and then a number, permit 10. So this is my route map for weight. And then I will type set. Look, there are lots of things. Which one is better to choose? Here, weight. So set weight. Set weight, a value for that. I'm gonna add 4,000 maybe. Now it is done. If we do show run, we'll see that that weight is just added. Look at here. Yeah, route map weight, permit 10, and this is the weight. But what do we need now? We have to add it here to that interface. Actually, we use that for eBGP. So we need to add that weight to that interface to change all of the weight numbers. How? Go to the router BGP 4 and neighbor 192.168.4.1, and the routes map, the name. What was the name? WEIGHT, inbound or outbound. So I would like to add it like inbound, and that's it, it's done. So if we do show IP BGP, we'll see weights are still 0 because just, you know, we've done a change. But as I've told you, what should we do? We should, whenever we do some sort of manipulations or changes, we do need to just reset that thing. So do clear Ipvgp star. If I hit the enter now, all of that networks will be reset. And it's going to start from scratch. But maybe just we can do for the inbound. They call that a soft reset. And if we try to see that again, we'll see, there you go. The weight is changed. Look, all of them are changed. This is the way that you can try to balance your traffic. In this way, I'm telling to the AS, this router or this path has the highest weight. Look, before doing the changes, if I can find it, I'm sorry. Look, for example, here, the best path was this one. Why? Because weight of all of them is 0, and the local preference, look, this one was 0, metric was 0, 0, and or based on local preference or also maybe the path, this one has the shortest path. So the router have chosen that one, but you know what happened here? Look, this is the thing that due to that weight, which has the highest priority. So, but I'm gonna do what? I'm gonna just change that because I will just type a no here to do another thing for the inbound traffic. I would like to do something else with access list. I'm gonna add another route map. So type route map. Before that, let's go for the access list. So access list and number, I don't know, for example, 99. And let me show you. No, we have that here. Look, for this network, which is here, the best path, this number will be 0 pretty soon. But imagine this is 0, so the best path will be this one. But I'm going to do what? I'm going to tell that whenever you want to go to that one, due to the thing that I'm going to apply to you, due to the local preference, you should go via this way, which will be maybe not a good option. But this is the policy of me, the service provider or the owner of the system. So another route map, no, sorry, access list. Maybe 99, just a number. Just giving you a number. Permit. What IP address? I'm going to work on this network here. So 172.16.21.0, and the wildcard would be 255. And yeah, this is the access list. So let's make the route map. Route map. After that, what do we need? A name. We're gonna local preference. So I'm gonna call that local preference. And then what do we have? Permit, another number, permit 20. And I think we're done. Yep. So inside that, what should we do? We should do something more. The first thing is we do need to type match. Match what? Here, IP. So match IP address to 99, which was our access list. So match it to 99, and I'm gonna type after match. Sorry, set. The last time we set a weight for that. Here we set local preference, and then we'll come up with a number. So maybe 999, something like that. And the same procedure. So go to the router BGP4 and to the neighbor. What was the neighbor? This neighbor. So neighbor 192.168.4.1 and route map. What was the route map? Local, I think. Local preference. Again, inbound. I'm gonna try to add that inside. Whenever we call that as inbound, we're gonna add it to this router. So when this is inbound, we add that inside the router when we just use it as outbound, it will go outside. So anyway, we're good. So in, and again do clear Ipvgp, and we need a star, and for the inbound do show Ipvgp. Was the rest of that? Maybe now it is okay. Not yet. Not yet. We should wait for that. Yep, we can see here. Look, the local preference has changed. And now the best route for that is the other one, because we've changed the local preference. So this is the way to change the local preference. And maybe we can just do the same, just type no behind that, and again clear all of them because there is no policy here. So these are the parts which were related to local preference and wait. So let's go to the other router, which is this router, it's H router, and do show Ipvgp. Let's see what we can do here, or on which of them. Maybe on this one will be good. So the thing which was important, when we add something as just inbound or outbound, it will be updated or it will be uploaded on all of the networks. As you can remember, on the wait, when we just add a wait to the system, what happened? All of them changed. But when we did it with a access list, just the desired system has changed. So it is the difference and importance of that. Maybe you just would like to do the manipulation or tweaks or changes on a specific network. So you should bear that in mind. This is the application of access list. So the last thing, but I'm not going to make that video more tiring. Let's see, for example, for that network maybe, or for the rest of them, it's not important. I'm going to do what? I'm going to change something. Look at here. We should find something that has the same path, the same AS path. Or here, maybe, yeah, this one is perfect. There you go. What do we have for this one to the AS2? We have two paths. Both of them, the path is the same. And look, for one of them, R9 is going here to the AS number 1. Let me put it this way. Yeah, it is better. So here, R9 is going to the AS1, and from AS1 going here. And the other path, and this is the path, I think this one is chosen. No. It comes here, and from here goes directly towards that. So we have two different paths, and we're going to change it. How? I will show you. In both of them, the AS number 2 is the second path. So what should we do? We should go to the AS number 2 and do the changes and do it as outbound. So which one is the AS number 2? This one is AS number 2. We can come to the AS number 2, or maybe this one at R7, maybe better. Yeah, we're here. We would like to change. Yes, here the route that it has chosen is that come here and go there. I'm gonna do what? How to change it? I'm gonna increase the AS path. Go to the R7, exit, again, route map, and come up with a name. I'm gonna do what? AS path. So just choose a name, maybe, I don't know, AS, something like that, and then permit, for example, 30 or 10, not important, 33, perfect. And now we should set AS path and then prepend. So maybe 96, 96, two numbers, whatever you want. And go to the router, router BGP, the AS number is 3, and we're gonna work on this one. So neighbor, which neighbor? 192.168, that's 6.2, and the route map is, what is the name? ASPATH. So this one now should be outbound. I'm gonna add everything towards that. So out and hit the enter. So we should come here now on R9. This was the thing that we had. Look. So again, do clear Ipvgp on out policy. BGP, I'm sorry. BGP and outbound policies, go to R9, show Ipvgp, and see what happened. These numbers added. These are the whole concept of the manipulation. You can do it with IP prefix, but if I'm going to talk about that, maybe I have to talk about, I don't know, 1 hour. So these are whatever that I wanted to tell you, whatever was important to have good understanding of that, different AS, different path, how to change, and everything. That's it. You should just, the best practice is that have hands-on experience on that, work on that, and if you have a question, you can ask in the comments. If you like the video, just show a thumbs up, hit on the like button. If not, thanks for watching the video. Don't forget to subscribe to the channel. Bye everyone.